Get about 1K lasers on it, 170K when it's off. It's on, there's off. All right, what we've got here is the Arduino IDE software, and this is the code for the laser harp. We've got set up right here. I've got the Arduino connected to the computer with a USB plug, and my signal output, let me zoom in a little bit right here. Signal for the Adafruit, I've got an auxiliary cable hooked up to a speaker, and we've got the harp currently playing through the speaker. What we're gonna do is use the serial monitor tool in the Arduino software to measure our voltage. So how this works is we're using the analog inputs on the Adafruit shield, which is connected to the Arduino, obviously. And those signals are coming from the photoresistors that the lasers are shining on. As the light changes, the resistance changes in the photoresistors, giving us an analog signal. We can measure this voltage using the serial monitor on the software. So what we'll do, let's look at the software real quick. So right here on the top line, this is where we've started writing to the serial monitor, serial.begin 9600 baud. And down here, I've got it set up serial.println PR2. What that's gonna do, our second string this guy right here, he's gonna write the analog signal PR2 to our serial monitor. So let's go up here to Tools, Serial Monitor, and it's going. So it's reading real time. If I go over here to the harp and block that laser, our analog signal changes to about 245 or so. And if it's not blocked, it's about 922. So what this means is when the laser is not blocked, we're going to get a digital high from this analog value. The scale for the Arduino system is 1024, and the scale runs from 0 to 1023. The 0 side is a digital 0, the 1023 side is a digital 1 from an analog signal. The way that Arduino interprets this information, anything 3.5 volts or higher is considered to be a digital 1, while anything 1.5 volts or lower is considered to be a digital 0. On my calculator right here, I took the liberty of punching this in beforehand. I was measuring my analog signal earlier was 927. If we take our 5 volts and multiply it by 0.927, we're getting 4.6 volts, which is above 3.5 volts. So this is a high. As long as the laser is not blocked, we're going to get a digital high. I was also measuring when the laser was blocked at 0.25, which that will correspond with a digital 0. If we look back over here at our serial monitor, it's 923 right now, but that's our high, digital high. If we block the laser, 245 right now, 243, analog signal. Stop blocking it. There comes the analog signal. Back high, back low, high, low. So here's the code for the laser harp now that the project is complete and the program is running completely. I thought that we could go over some of this since I wasn't really able to submit any type of code week 4 of this class. Work and such, I wasn't prepared. And another thing that has made the code take longer is the MIDI setup. So that's some stuff that I want to look at to see the difference, what was mine, what I used from forums and examples and helps from online, mostly from the Adafruit website. There were a lot of good tips, tricks, and helps that were very beneficial. But if we look up here at the top, this is part of the setup. If we look right here in this area, this is all set up, used for setting up the MIDI shield, the Adafruit shield. And you'll see throughout the program it's referenced this VS1053. This is the chip that is used on the Adafruit shield. That's the chip. So we'll see that referenced throughout the program. I also left some of these things that were in just for my use at the time. These are all links that you can click and it pulls you up to the data sheet for the chip, the VS1053. This was very useful for the setup. This was very useful for getting the shield to actually work. This part at the top, obviously that was pulled from examples, helps and such. This part right here, this is for setting up letting the Adafruit shield know that I'm using an Arduino Mega. We'll come back to this. This line right here had me stumped for a long time. It was causing a lot of problems, but we'll come back to this in a moment. Further down the program, all this through here, this is all original. This is all my code. Yeah, up through here, this is all original. And this section was pulled from one of the examples on the Arduino. So Arduino has, if you download the library for the VS1053 chip, we have example sections, and then here at the bottom we have the Arduino VS1053. This is the MIDI shield. And if we go down further, we can look at a MIDI test. So here in the MIDI test, this has a lot of, well, not a lot, this had quite a bit of the stuff that we referenced. Some of it had to be tweaked. I wasn't able to use all of it, but this right here, this was the section on the other program, my program, that I mentioned caused so much problems. What happens is this line right here, this is if you're using an Arduino Mega or Leonardo. So what this is supposed to do is have an if statement. If you're using, you know, the Mega or Leonardo, it'll set it up as such. Else, if it's not, it'll do this. So it's a pretty simple if statement that's supposed to kind of read the hardware and see what's going on, but it wasn't working properly. And I wasn't aware that this was what was causing the problem. So what I did in my program, if we go back over to my program, what I did was I just cut out the if statement and I left it just setting up the Mega, forcing it to set it up. If we look a little bit further up here, there's a hardware setup for the Mega as well. Right here, the RX2, if we look back on Adafruit's website, this is for setup for the MIDI. This is what enables the MIDI output. There's two things that are actually done physically on the board. We short digital 2 to RX right here, and then the GPIO1 is shorted to 3 volts here as set up on my project. So those were two things that took a while for me to figure out, and I was actually stumped on it for quite a while. This section I was very happy with how it turned out. This took a little while for me to figure out how to get it to work, because This works similar to a buzzer keyboard Arduino project. It's similar, but it's very different. It's not something that I was able to reference too much. I was able to reference the theory, not really the command lines. So setting the analog inputs to these integers with an analog read allowed me to take this information and then play the corresponding note should the analog value change drastically. So with the shape of the laser harp, some lasers were closer to the photoresistors than others because of the shape. And some of the lasers had to be what I would call calibrated a little bit. Further down here, there's a larger threshold for the lasers. What I kind of thought about it as is kind of spillover light. When the laser would get blocked, if it was too far away, the lasers from the light from the neighboring lasers would not let the note go low, so it would just not play. Adjusting this value kind of compensated for that spillover light and made it to where it was still working. Obviously these are all the strings here. We have our PR, that's our photoresistor 1 through 8, analog pins 0 through 5. This is where the shield kind of got in the way physically, so we just grabbed analog 10 and 9 here. This is a little bit further away from the analog shield, the Adafruit shield, so I took advantage of having the additional analog pins. This was actually the reason we had to go with the Arduino Mega instead of something smaller, because of the number of analog pins required for this project. As I stated in another video, the serial print LN here, I had it set up while testing PR2. I put that in the demonstration. This was used for actually determining the voltage and making sure that the signal was getting through. This was very useful for troubleshooting using the serial monitor. This was very useful to ensure I was getting a 1 or a 0 from an analog input when I was supposed to, and it was very useful for that. But other than that, I think that fairly much covers the code. The Adafruit community was very helpful for getting this to work. Apparently, setting this up for an Arduino Mega is not something that's regularly done, so some of the issues I was having, not everyone was fully aware of, and overall I'm very happy with it. The setting up the MIDI was obviously the hardest part. I really struggled with that, but I was able to get it fixed last minute and had the project working in time for the presentation.